Hi, welcome. This lesson we're going to be talking about solving quadratic equations by taking the square root. So we've got some questions to get you started here. How many numbers can be squared to get 9? In other words, what number can you multiply by itself to get the number 9? So just let you think about that for a moment. In other words, how many solutions are there to the equation x squared equals 9, which again is some number multiplied by itself 2 times equals 9. What are they? Also, what about the equation x squared equals negative 9? If you're watching this video with more than one person, pause for just a second here, pause the video, and discuss those questions. All right, hopefully you came up with some answers here, but we're going to come back to those questions here in just a moment. All numbers except 0 have 2 square roots. A positive square root and a negative square root. The square root symbol means the positive square root. Both roots must be considered when solving an equation by taking square roots. So we use the plus or minus symbol to include or indicate both roots. All right. So let's go back to this idea of x squared minus 9. If I take the square root of x squared, take the square root of 9. I'm taking the square root of both sides. When I do, I have both the plus or the minus value of 9. And the square root of 9 is 3, and so this is x is equal to plus 3 or minus 3, which we, again, typically just write as plus or minus 3. That's two values, positive 3 and negative 3. All right, the number I, you recall from our earlier studies, the number I is the number whose square root is negative 1. That is, I, the imaginary unit I, is equal to the square root of negative 1. And I squared is equal to negative 1. So an imaginary number or complex number is a number that can be written in the form a plus bi, where a and b are real numbers and b is not 0. For imaginary numbers, any number with an I in it is imaginary. The square root property. If b is a real number and if a squared equals b, then a equals plus or minus the square root of b. And this is what we use here a lot for taking the square roots of quadratic equations. The radicand is the number under the radical sign. So the square root of 9 in this case is the radicand. So when we're solving equations by taking square roots, we do this when the equation has a perfect square and no other variables. All right. Some examples. Solve each equation using the square root property. Include both real and imaginary solutions. Write your solutions in simplest radical form. Write imaginary solutions in the form a plus bi. Okay, let's look at x squared equals 50. So the opposite of taking the square of something is taking the square root. And so we take the square root of x squared and we take the square root of 50. Always remember that we have a positive and a negative square root. So there's plus or minus. And then we've got x then is equal to the square root, or plus or minus the square root of 50, but we want to see how do we simplify this. So we say 50, 2 will go into 50 25 times. 2 will not go into 25, so we go to the next prime factor, 3. 3 won't go into 25, so the next prime factor is 5. 5 will go into 25 5 times, and so the prime factors of 50 are 2, 5, and 5. Since we have two 5s, those can come out of the radical, so we write this as plus or minus 5 square root of 2. 2, not having a pair, is the one that stays underneath the radical. And that then would be the two solutions of x squared equals 50. Let's look at b. So in b, we've got 3d squared is equal to 48. Before we take the square root, we want to isolate the part that is being squared. And so in this case, we're going to divide both sides by 3. Then we get d squared is equal to, and 48 divided by 3 is 16. And then we do the opposite of squaring, which is take the square root. Remember to add the plus or minus. D then is equal to plus or minus, and 16 is a perfect square, so the square root of 16 is 4. And that's the two solutions. Remember, this is two numbers, plus 4 and minus 4. All right, let's look at example C. We've got 2n squared plus 4 equals 104. Once again, before we take the square root, we need to isolate the part that is being squared, which is just the n squared part. So first we get rid of this plus 4 because it doesn't have the variable with it. We do that by taking the opposite. Since it's add 4, we subtract 4 from both sides of the equal sign, eliminating the 4, leaving on the left 2n squared is equal to 100. Then we take and divide both sides by 2 to get that n squared alone. So the opposite of multiplying by 2 is dividing by 2. And we do that on both sides. So we get n squared then is equal to 50. And then just like the other example where we had something squared is equal to 50, we're going to get, move that over a little bit. We take the square root of both sides. We add the plus and the minus. N then is equal to plus or minus. We've already simplified this, so it's the same, 5 square root of 2. And that would be the solution in this case. All right, let's look at D. Moving right along here. 3q squared plus 6 equals negative 48. So I'm going to get rid of that plus 6, subtract 6, subtract 6. Cancels the 6, leaving 3q squared is equal to, and negative 48 minus 6 is negative, negative 54. And then we divide both sides by 3 to get rid of the 3 that's by the q squared. And we get q squared is equal to negative 17. No, not negative 17. Negative 18. Right, 18. And then I take the square root of both sides. I'm going to copy this up here, and I get the square root of q squared is equal to plus or minus the square root of negative 18. And then I'm asked myself, with the negative on the 18, that's going to give us an I. If you remember, the square root of negative 1 is I. And so we need to simplify the 18 also. Look at 18. 18, 2 will go into 18 9 times, and then 3 goes into 9 3 times, and these are all the prime factors. Since there's a pair of 3's, that will come out, and q then is equal to plus or minus 3i square root of 2. Because the square root of negative 1 is equal to I. And so the square root of negative 18, the square root of negative 18 is equal to the square root of negative 1 times the square root of 18. And so we take and simplify the square root of 18, which is 3 square root of 2, and the square root of negative 1 is I. And so this is our final answer for that problem. And then we go to E. We say 16 equals y plus 1 square root. And here, the square root is all of this is already squared. So it is also already alone on that right-hand side of this equal sign. If you prefer, you can switch it over to the left. I think it's fine just like that. So we're going to take the square root of 16, again, plus or minus, is equal to the square root of y plus 1 squared, and those going to cancel that square. So that leaves y plus 1 is equal to plus or minus, and the square root of 16 is 4. So we then are going to subtract 1 from both sides. So we get y, these cancel. We get y, and this is negative 1 plus or minus 4. I'm going to copy this up here. I'm going to switch sides that one. Y equals negative 1 plus or minus 4. And here we're going to separate this into 2. This is negative 1 plus 4 or negative 1 minus 4. Taking both the positive value here and the negative value over here. So there's the plus 4 and the minus 4. And negative 1 plus 4, that's 3. Negative 1 minus 4 is negative 5. And so 3 or negative 5, which you can write as the solution, say y is equal to the set of negative 5 or 3. Could be either one of those numbers would make this solution up here correct. All right. And then finally F. We've got our part that is inside the square. The squared part is just this part that I've highlighted. Is just m plus 5 quantity squared. So we need to get rid of that 2. And it's multiplying the parentheses. So the opposite of multiplying by 2 is divide by 2. So we divide both sides by 2 and we get m plus 5 quantity squared is equal to negative 25. And then we take the square root of both sides, taking the plus or the minus values. And that leaves us with m plus 5 on the left, because the square root cancels the square. And then on the right, we have plus or minus, and the square root of 25 is 5. The square root of the negative 1 is I, so with plus or minus 5, I. And then we subtract 5 from both sides. Subtract 5 from both sides of the equal sign. And that gives us m is equal to negative 5 plus 5i, or negative 5 minus 5i, and is perfectly okay in this case because there's nothing that you can do to combine negative 5 and 5i. They're not, you can't combine the real and the imaginary parts. This is the real part, and this is the imaginary part. And so you can't combine your real and imaginary parts. So I can't simplify that any further. Negative 5 minus 5i for the same reason. So it's okay completely to write your answer as minus 5 plus or minus 5i. And that would be your final answer. But it is the same as what we have written up here. Plus 5 minus 5i, plus 5i, and plus negative 5 minus 5i. And both of those are equal. All right, that's how we do this. You have any further questions, please ask your teacher. There's lots of resources online. Best of luck in your practice. Have a good day.